So first, let me focus on the comprehension, then I'll come back. See, comprehension, the major usage of comprehension. See, basically we talked about the for loop before this and the while loop, etc. So what we generally say, so possibly for I value in, let's say, 1 to 4, then we'll say, let's say print I. This is a common scenario. Or possibly we say, so the same example if I take, I'll write it in both the ways. So possibly we are saying hello names and we want to do a simple hello, or possibly we'll take this. There are numbers and we want to take out the numbers. Okay, I'll write both the ways for you. Possibly the numbers are this, right? So if I do the traditional way, what is that I say? If I'm not using comprehension, for num in numbers, for num in numbers, then I'll simply say if num percentage 2 is equal to 0, then I'll simply say print, right? Print num. I'll say print num. Then I'll say else oh sorry, I'll have to put this, else print num comma num star num. So the same problem wherein I am saying, so possibly if these are the numbers, if it is even, do this. If it is odd, do this. Okay. So possibly you are getting something like this, but so possibly we may. So here we are combining both of them. So the first one is odd, so it is printed 55, 3025, right? So this is one way to write and print. Whereas now if you look at this for loop, actually these are two different problems. We have combined them into one, right? Possibly I would otherwise remove this else block here, right? For if it is even, just print the number, otherwise don't do anything, right? Print and we'll say end equal to this, so that it will print in one single line. So if I run this, I'll get 32, 10, 54 and 32, right? These are the even numbers. Now the second problem is, again you do this for num in numbers is equal to 1, which means it's a odd. Print num comma num square. So this can't be indented. It is taking indentation. Oh, sorry. So I have to remove the indentation, but this one I have to put the indentation. And this one again has to go into indentation. So now if I run it, I'll get the 2, or possibly I should put one more print just like a break. Now if I run this, so I will be getting something like this. Possibly I can do the formatting of the things accordingly, right? And I can very well get the values like this. Now what is happening here? Here I'm writing one line for I'm writing one line for if, I'm writing the action. So 3 lines of code I'm writing, right? Whereas here I'm actually writing one line of code, right? Because if you see here, all 3 for, so for num in numbers. So this is one part of the code that we have. Then if num percentage 2 equal to 0, that's the second condition. Then print just the num. So that is what we are doing here. Whereas here it is doing all 3 in one single line of code. One is what needs to be done for what set of values, and what is the condition that needs to be looked at. So if you are having all 3, you can very well go ahead with the comprehension. Did you get it? Otherwise, I mean, it's not a mandatory. Otherwise, you can write code like this, or you can write code like this. So this is like slightly longer way of writing, whereas here it is more shorter way, but the activity that happens internally is one and the same. Are you clear on the comprehension? Whosoever has asked the question? Kushagra. Then import. Import, I think we'll wait, because actually what will happen, I'll have to define this Google Drive link. Here I just manually copied this link, right? So possibly what I'll show you slightly later is once we have drive mounted, once we have mounted the drive, right? So possibly you should, we will look at that part. Once you have mounted your drive, then easy, you can change the directory, ease of access. So wait until pandas, right? That way possibly I can connect to a Excel file or something that is lying in your Google Drive, and I'll have a detailed part associated with it. So right now, just hold on in case something is not clear also with respect to the input output, especially connecting to the Google Drive. Okay, so you can just park your question for 1 or 2 more sessions. Okay, so I think I'll get on to the today's session. Right, I'm taking a new notebook. I'll share this new notebook at the end of the class. So the topics that we are going to look at here, one is the modular programming. This is a very, very important point in good programming, especially when you have repeated things that you are trying to do, right? Repeated calculations that you are trying to do. It's better to keep that calculation in the form of a function. Function is executing the same calculation, right? But every time you don't need to write the code for the calculation. You write a function once and you start using the function from the second time onwards. So that way you can very well, that is what is the package all about. I mean, package is slightly bigger, but in the packages, that is what is happening. Package, whatever is the package that you have imported. In the last class, we talked about the math package importing. Now, so package is nothing but it's a set of functions, list of functions that people thought would be helpful to the other people in a specific domain area. So they created a function. they put all those functions as a part of one package. So right now we will not go into the package concept, but we can create a list of all functions and we can create it as a module or a kind of a Python file in itself. All the extra functions, you can create it as one Python file and you can very well import that Python file also into your program. So today we will primarily look at creating a function. How do you create a function? What is a function? How do you create a function? So that is one part. And after that, we will move on to one of the most widely celebrated libraries, which is the NumPy library. Right? Of course, the basics of NumPy is what we will look at. For all the modules, for all the libraries, we are only going to look at some of the basic elements so that you get some little bit of comfort with Python. Right? I did not wanted to more than 4 or 5 sessions on Python, but looks like with many of you coming from the very basics of Python, possibly we may extend 1 or 2 more sessions of Python, but definitely you will learn more and more as we start solving some data science problems. So possibly I'll just give you some basic flavors of NumPy pandas. But when we really get into the data science based problem solving, wherever some additional features of NumPy and pandas and Seaborn, etc. are required, we will use them in the context. So in the pandas itself, I will start off with the actual data which we are going to use in data science, right? So that way a little bit of more consolidation can start happening. So today, if possible, we'll look at the modular programming as well as the NumPy aspect. So modular programming, modules, you create everything as reusable module. Module itself, the meaning wherever you talk about module, it's a kind of a building block which you can reuse. So Python also provides various constructs to enable code reuse. So right now our focus is only on the function, but objects, classes, lot of other technical stuff is there where a modular programming can come into picture. But here let's focus only on the function. Functions, classes, modules, all these can very well be reused as we have already talked about. I create a library, I can very well reuse that entire library. So for reuse, there are various aspects that are available in Python. Now read through it. What is a function? It's a useful concept that groups together a set of statements. So in lines of code, instead of writing one line of code, we may write a few lines of code which are nothing but few operations. We may write few operations and we may group all of them by just one name. So which means possibly it's like, let's say I want to compute for a particular given data. I want to compute addition, subtraction, multiplication, division, right? Or in the statistics, I want to compute, let's say, mean, standard deviation, skewness, kurtosis, and possibly some other median and some other computation. So multiple activities with just one line of code. So what we will say, we will create a function of all these activities one after the other. We group all these activities into one single name by giving a one single name and say that that is a function. Save it as a function. So because of that, from the next time onwards, I can simply give the name of the function and I will get all the calculations that are required. So that is where we say function is a set of statements so that they can be run more than once, especially if you think some set of statements need to be run more than once, then it would be better that you create them as a function. And sometimes the function can run in isolation, which means without any inputs given to it. And in some cases, a function requires a couple of inputs and it runs based on those inputs. So those inputs are typically called as the parameters of the function. So in some cases, the function may run without any set of parameters, whereas in many cases, a function will run based on some set of parameters. It will do some kind of computations for us. So the prime advantage of a function is avoid repeatedly writing the same code again and again. So wherever you notice that you have to execute the same functionality on multiple data columns or multiple data values, it is better that you spend some time to write a function and reuse that function. That is one way to optimize your coding. Okay, this is one of the most basic levels of reusing. And I think to start with, if you know at least this, possibly objects and classes require a little bit of more technical understanding, but functions can very well be created by anyone quite easily. Now, how do you create the function? We will use a keyword called def. Def is definition, right? So defining the function, you'll have to initially define the name. So probably you can look at this. I say def name of the function, and if at all it takes any input parameters, any inputs, you specify all the inputs with comma separation. So arguments are nothing but inputs to the function. And these inputs, they could be mandatory inputs, right? And in some cases, they could be optional kind of an inputs also. They could be mandatory inputs, they could be optional inputs. We'll discuss about each one of them. So, and after that, you will have to specify one statement called return. Return is the one that would actually give me whatever is the output that this function. So the function takes inputs called argument 1 and argument 2, and it returns the desired result. So you will have to uncheck this, unhash this, and it will return the desired result. Whatever you specify in the desired result location, it will return that output, right? And that particular return value could be an optional value also. Sometimes it need not return anything also, or whichever is the last value that is computed, it will return that particular value. You can consider any number of parameters, Nabi. You keep putting a comma to it. I'll show you some other ways of doing that also. You can have any number of parameters. We have a few examples to look at that. Sometimes the parameters, if you already know that this takes only 2 parameters. Let's say I want to add, right? I want to add A and B. Or probably I want to give A and B as 2 values. And it will compute A plus B, A minus B, A multiplied by B and divided by B. So what is happening here? I know that it will take only 2 values as input here, because this function will only compute, or possibly it will say Along with computations, it will also say whether A is greater than B or not, right? It will also compute the average of A and B. Possibly you can create some more. But at any end, at that point, in this problem, it is only taking A and B. But if you say, I want to do this with A, B, C, and if A, B, C only for 3, then still you can give arg1, arg2, arg3. But in some cases, you may want to keep it more variable. Whatever is the number of input items that come, right? Whatever is the number of input items, it may be 2, it may be 3, it may be 4. I should be able to consider all of them. In that case, we will use this mechanism called star arcs. Right? We'll use this mechanism called star arcs. Means the number of parameters is variable. I don't know whether it is 2 or 3 or 4. Whatever is the number of parameters, my model should be able to address. So that is where I use the star arcs. We have some examples. So, and the KW arcs, the star KW arcs, again for a variable number, but here they are keyword associated arcs. Just wait for some time. So they are keyword associated variable number of arguments. So we will discuss about these things, right? But the most important ones are argn, comma, star arcs. Star arcs is when you want a kind of a variable in terms of your parameter. Now, sometimes when you write your function, you will get some help, right? Probably the other day also when I was writing one function, I was actually possibly if I put my cursor somewhere, it was showing me all this. Now you see in range function, it was doing arcs and it was doing KW arcs also as input, right? And after that, it has given a lot of text here. So the text is the kind of documentation, right? The text is a kind of a documentation. So what you could see is if you write your documentation in between the 3 single quotes like this, starting and ending, that is what is the documentation help for this function. So if you are using this function anytime, anywhere, you will get this help message. So it was always a good practice to write some kind of a help message whenever you are defining some function, especially a very complex calculation related function. If you are developing, it's always better to write some kind of a notes for it, along with what each of these arguments typically denote. And sometimes you don't need to give any arguments also. Possibly you look at this. So we are saying just the same, hello. I'm just saying say hello. But rather than directly printing say hello or printing hello, I'm defining it using a function. So I'm using a def, the name of the function, open bracket, close bracket. And if at all there are any parameters to it, I'll pass it. Right now, I don't have any parameters. So I'm not passing anything into it. And I put a colon. So just like the way there is an indentation that happens, print hello. Just a very basic. So this is what is a function for me. Very simple function. So its job is only do whatever is there inside this definition. So when I have to call this function, Just say hello with an open bracket. That's the name of the function. And the instruction that is there inside it is print hello. So it will give me the output of hello. This is a basic function. We'll build on it now. Parameters. So these are, so here we did not have the parameters, but arg1, arg2, args, kw args. They are all the parameters. Parameters may or may not have default values. Sometimes for some parameters, I may give a default value. Like if I don't give the value of, let's say I'm putting a comma b, I'm saying some function, all calculations a comma b, right? In that case, what happens is the user has to define the values for both a and b. If they fail to define, it is mandatory. If I'm simply writing def arg1 comma arg2, it is mandatory to give the value of arg1 and arg2. Otherwise, it will give me an error. So what sometimes people do is they try to give some default values for arg1 and arg2. So they may say arg1 equal to 3 and arg2 equal to 5. So that is like a default value. So if you don't give the explicit value for arg1 and arg2, it will take those default values of 3 and 5. So that is if there is a default value. And if it does not have a default value, you have to explicitly give a value for a and b. And if you don't give, it will give you an error. So that is what is parameters having a default value versus not having a default value. Then a function's parameter can be passed either by position or by key name. What does that mean? Okay, we will discuss about it. So possibly we'll write a couple of more functions and then we will discuss each and every. This we have already talked about. A function can accept a variable number of position arguments. Variable number of positional argument. Okay, I think I have to talk about the positional argument. So a functional parameter can be passed either by position or by key or name. So we have already written here, right? I'll say def some trial function a comma b, and possibly we will say some, or we will directly say print a plus b, a minus b, a into b, a divided by b, right? So possibly we'll write it just to understand it. Def trial function a comma b. Print, right now I'm writing it very simple. Sum equal to Okay. Okay, something. So now I will define this function, and in another block. So in this block, I am just defining the function. We will improvise on the top of this. Now I'll have to give value. So I'll say trial function 24 comma 3. I'm just giving 24 comma 3. So it says sum is 27, difference is 21, product is 72, and quotient is 8. So these are the values that it has printed. So here we have given 24 comma 3, and it has taken A is 24, B equal to 3. Right? We have defined A comma B here, but here I did not say A equal to 24 and B equal to 3. I simply said 24 comma 3. So this is what is passing the parameter by position. So when I give this function, A will take 24, B will take 3. So that is what is like position, right? And in some cases, we can also say key name, which means here I can very well omit this, and I can initially say B equal to 3, A equal to 24. So here I'm changing the order, but still because I'm mentioning what are each of these parameters, finally the calculation will be the same. So if I ignore giving the key or the name, then I have to follow the order. Otherwise, I have to specify the key or the name. That is where this line, a function parameter can be passed either by position or by key or name. That is what it means. And in some cases, while defining the function itself, we can give a kind of a default values. So possibly we may say B equal to 5, and A I don't give any, let's say, a default value. So what will happen in trial function, right? In trial function, if I don't give, if I give only one value, let's say 50, what will happen? This 50 will be assigned to A, and B will be taken as 5 by default. So you could see here the sum has become 55 because for B there is a default value that was given, and which means it has taken all calculations based on the default value of 5. That is how the functions will come into picture. So that is where we say it could be having or not having any. So if I don't give any, I have one non-default value. A does not have a default value. So if I don't give any input in the trial function, it will give me an error because it is missing one positional argument A. If I don't give any default value, right, that positional argument is typically missing. So at least I should give for one of them. Then, okay, let's look at I think we'll come back. The function can accept a variable number of position arguments. So here, the position arguments we have given as fixed A and B, right? So in some cases, it can also take a variable number of position arguments. We'll just see in a while. How are we looking at the variable number of position? Position arguments are, so this A, B, so we are not actually saying A equal to 100, B equal to 5 or something. We are just giving in the order. A function can accept a variable number of keyword arguments. Just we will see the keyword arguments also by ** KWRs. Function parameters are passed by object reference. So as we have seen, A equal to this, B equal to this. So the parameters are passed into the actual function by using a object reference. So let's look at a few of them, and I'll take, once I am done here, I'll go, or possibly let me look at the questions first. Then I'll go back. All right, arg1 and arg2 are parameters. Can I write the function expression? Can I write the function expression outside of print? I did not get the question. Outside of print, function expression. Yeah, you can write all the expressions in one line, and finally you can do a print also. Or in some cases, you don't want to print anything. You just want the values to be returned also. We'll see. What if arguments of definition is different from function call? What if the arguments of definition, so arguments are arg1 and arg2, is different from the function call in keyword? Is different from the function call in keyword. So, I mean, possibly I'm not getting the question clearly. What if the arguments of the definition def arg1, arg2 is different from the function call? So you don't use arg1 and arg2 in the function. If you don't use, obviously it does not get the required values, so it will throw an error. But if I did not understand your question, possibly you can explain it. Can default values be overridden while calling functions? Yes. I think our friend has already explained it. Yeah, we are going to write them. How to introduce optional argument? What is option? Okay, argument, that is, we have right now, we have given, right, default. So if once I give some default, it means that if I don't specify any argument, it will typically take. So you can very well say default is null. So if something is not given, it will take it as null. In that case, it becomes an optional argument itself. So let's spend some minutes, a few minutes, to try to answer these. So default argument we have already discussed, which can be changed, but their value remains the same if not given. So, okay. So let us say here, I want to do a simple doubling of a number, which is just return number times 2. And possibly I may want to print that number as well. So what is happening? You just see def double the number. Num is one argument that I am giving, but I am giving a default argument there. I am giving a default value to the argument num. And it is saying return num square num times 2. And I'm trying to build the print function. So I'm not giving any arguments function because there is a default argument and it will take that. But if I simply say print double the number, it prints 2. But if I put it 10 as an argument inside, it will print 20. Right? If I put an argument, it means it is overwriting. If I put double the value there, okay, this is not a positional argument or just. Okay, so I was talking about the arguments here. So default arguments here you could see print double the number, and I have given 10 in the bracket. Then obviously it takes it as a positional argument and it overwrites the default value that you have given and it prints 20. Similarly, we talked about the positional arguments as well. The positional argument you will give with an equal to sign, right? So you are simply doing so you are not giving any default value, and which means the num is the first value, so first parameter. So if there are multiple parameters, let's say num1 comma num2, then we are returning num1 divided by num2 into 2, and I'll call it new calculation or something. And I would simply say, instead of saying this, new calculation 1 comma 2. So obviously it will take num1 equal to 1, num2 equal to 2, and then it will do the necessary calculation. Right? So it is 1 divided by 2 multiplied by 2. So the value is coming out to be 1. So positions are always in the same manner. Now, this is where you can think of. So positional arguments will always precede the keyword arguments. So keyword arguments are nothing but the argument that you are giving in this manner. So positional arguments will always be in the beginning, because whatever you enter in the beginning, the first parameter value will associated with the first parameter. Second parameter value will be associated with the second parameter. So whatever are the positional arguments that are there, they will be first taken and the keyword arguments will be taken later on. So the keyword arguments are the arguments which we are going like this. We are giving a keyword, key value kind of a pair. So those arguments will be coming later on. And if there are any dynamic number of arguments also, we can very well pass those dynamic number of arguments as well. And if there are keyword based dynamic arguments also, you can clearly see here the keyword based dynamic arguments, you will pass them in the form of a dictionary, right? So you will pass the key. So as we move into the data science world, we will be seeing a lot of such kind of definition. But for the time being, you can very well see if the arguments is what you can pass in the form of a tuple, and the keyword based arguments you can pass in the form of a dictionary key value pair. So you can very well say, so here you can very well define it as, so this is the structure. arg1, arg2, which are positional arguments. arg3 is the keyword argument. The star args is like dynamic number of arguments, positional arguments, and dynamic number of keyword arguments. So you can very well print, and of course here return value. I don't know what is the value out here. I did not compute any value. Right, value is there, so possibly you can very well right now put it as return value, which means it's a kind of a definition. Right, the moment you are opening it up, then it has to return something. So I have to do some calculation. Right now it will just say this is a function. Now the return values are the other important aspect. Right, so every function, possibly to a large extent, we will talk about the return values. Right, so return value is whatever that particular function is returning. What is the output of that function? So a return value is a value that is returned after performing a specific operation in the function. So you can return multiple values. We have already seen a plus b, a minus b, a multiplied by b. It can return many such values. So multiple values is just a tuple of values. So you can write them in the form of tuples. You can put comma separated in a tuple, and it can return the values. So that is the tuple. Then so they can be opened into multiple variables also. Possibly you can take the 0th location as some, first location as the difference. You can even get that kind of a mechanism as well. Right, so normally this is the basics of a function. Right, this is the basics of function. Let me just see the questions. Okay, keyword arguments. See, okay, I'll take some variable arguments. Which function has a keyword argument? Okay, let me look at one particular function. We'll write one function with variable arguments also. So possibly we will create a function that can add any number of digits that are there, any number of inputs that I pass into that particular function. It will add all those values. So possibly let me create one particular function, sum any. So it can add any number of observations that you are passing on to it. So I will create it as star arg 1. That is the input that I am passing into it. So star arg is I am passing variable number of inputs. Right, so I am passing, once I put a arg1, so it need not be like one argument. It can be any number of arguments that can be given to it. So what do? I'll put a kind of a loop for argument in arg1. So whatever are coming as a part of arg1, right, I will say initially I'll say sum equal to 0 for argument in arg1 right? I'll say sum equal to sum plus equal to, which is sum equal to sum plus arc. So if I put something like this, so here I have given only one parameter, but I have put a star before that parameter. So obviously I can very well now, let us try now. So I'll say print return sum. So possibly I'll do this. I'll say return sum. And after that, I'm going to print this sum value, right? Or possibly inside this also, we can very well use this print because that itself could be a this thing. So now I define this function, right? Now, okay, I'm adding up the sum. So this print will take it outside. Okay. Then we will do a sum any. So let's say I do 1, comma 2, comma 3. Right? Sum any, I'm putting 1, comma 2, comma 3. Okay. This return also, I'll take it here. So you see, here I have given 3 arguments to it, but it has given me a result. Similarly, I take it to 4, comma 5, it will still give me. And in some cases, I can also give the other way also. I can first give a equal to 10, comma arg1. Then, so which means there is one positional argument or a keyword based argument and other is some extra arguments. So possibly I will start with sum equal to a. Instead of saying sum equal to 0, I'll start with sum equal to a. And from there, I'll go ahead. So that is what is my new function now. And based on this, okay, so here I should very well give I have to say sum equal to a, and while passing I'll have to give a position based here. Oh, sorry. Here I have to give I'll have to look at it. This is actually taking all of them. A, it has taken A as the first value, and all the other 4 it is taking as the argument. So possibly you can very well specify You can very well specify, I don't know, a and a dynamic number of argument. So at least one argument it will take, and that will take as the first argument. So if I don't give any, yeah, if I give like this, the first argument will be taken as a, and the remaining four arguments will be taken as the dynamic number of arguments. So that is how it will take. I mean, though we have given it, so it will, if we have given the first value, it will override this a, and after that it will, if you don't give any, that is where is the advantage. If you don't give any, it will take it as 10. Then if you give at least the one value, it will override that a and it will take as 3. And after that, if you start giving something, then it will take the remaining as the first one, it will take as a, and the remaining ones it will take as your arcs. So that is what typically happens when you are giving your star arcs. Whereas now when you come to your keyword arguments, which is, so I hope arcs is clear to you. So in keyword argument, you are providing a name to the variable as you pass into the function. You are giving a name to the variable as you pass to the function. So for example, you can very well say, possibly I'll try to write something. So we'll say that def function 1, right? I'm just passing on some keyword arguments, right? I'm trying to pass some keyword argument. So what you will typically say is, you will give it as a keyword pair when you are defining that particular function. So you will say 2 words for key comma value, because we are talking about both the values. The key also you will be giving, the value also you would be giving in. So here we have to pass it like a dictionary. So which means you will typically call KW arcs. KW arcs is there, and you take the items of the dictionary. So KW arcs comma items, which is the items of the dictionary, right? You will simply now, for each of these items, so we are passing it now in the form of a dictionary. So the first one will go for the key, the second one will go for the arcs. So I think I have to look at the syntax, the way you will have to pass. So it's a string that you will be passing. So I'll simply have to say, so right now you can reserve this. We can very well say whatever comes in the form of a string, you will map it to a string. So it's the format, you are giving it as a string format, the key you are taking it as a string format. And so you are, whatever you are taking, possibly you can call it as key comma value. Those are the values that you have considered. So whatever you have coming in this, we are taking them as key comma value. So that's the key value pair. And this is how you are passing the argument. So which means the argument, the keyword, the argument itself is in the form of a keyword. We don't know what is the name of the argument. So possibly, let me see if this works out. So I can very well say func1, and I will try to say, so because I can say, so I'll have to give it as key value pair in the equal to form, right? So I'll have to first mention first name. So if I say first name equal to Vamsidhar. Possibly this is the key. So let's go with the first name equal to Vamsidhar. And possibly I can say, or I'll say last. Oh, this is the pair, right? Last. Ambadipudi. First equal to Vamsidhar. Then middle equal to none. Last equal to, I think somewhere I made a mistake. So this is a percentage S equal to percentage S. Yeah, possibly we'll take it for a printing. Print percentage S equal to percentage S. And I will take this as, okay. For key in this. Let me just see now. Yeah. So it has given me, right? So what is that we are saying here? Whatever is the key and the value that you give like this, a string equal to string. So the first string will be taken as a key. The second string will be taken as a value. So you are passing some kind of a function. So it is directly taking the arguments on a dynamic note, right? You have given the, so it has directly taken keyword arguments, and you are passing on both the key and the value. So for the first function, you will say it will have to take based on for the Vamsidhar. So the first will be taken as a value called Vamsidhar. The middle will take a value of none, and the last will take a value of Ambadipudi. And any other calculation you do, so you can say hello first. You can very well start writing a function on the. I mean, you can write the calculations on the top of them. So keyword arguments, possibly when you get into the any machine learning algorithm, you will find a lot of such kind of keyword arguments, especially for one model. If I have to pass on some kind of parameters, I can pass them on like this keyword argument. So you don't know how many such kind of arguments can come, but for any kind of key value pair that is being given, you just format it like a key value pair. So that is how we are talking about the key value. So possibly you can very well look at a few other examples as we move further. But at least explicit arguments and implicit arguments is what you can very well look at. So I'm just printing whatever comes percentage S equal to percentage S form. String or string equal to string. So wherever there is a string format that is matching, you typically take it into the key value pair. So I can very well look at this kind of a scenario. The first, when I'm, so here I'm simply saying first is Vamsidhar, middle is none, and the last is Ambadipudi, which is my last name. So you can very well give arguments, keyword arguments, right? Probably as we move along, we can understand it even more better, because when we take a real world example, possibly it becomes much more easier. Because when you are taking, normally it is either your existing functions, or it could be, so if you are, let's say the other way of looking at, you are giving the keyword functions, right? And possibly you can very well, so other way probably we'll look at one more possible example. So you can very well say Yeah, I'll think of one more example and possibly I'll get back to you later. But yes, you keep on like you can give both key and value. So earlier we have just taken the value of the argument, but now we are taking both the key as well as the value. So the keyword arguments are always like some x. So arg1 equal to 3, arg4 equal to, so they are actually taking an assignment also. Items is just a part of the key for a dictionary. So if you have defined your dictionary correctly, so possibly you can share your screen and based on that we can look at it. Okay, yeah. So we have done with the return values. Now I am going to talk about the next function, right? Next important feature, which is the lambda feature. Lambda is just an extension of the function, right? Sometimes or many times, instead of the function, we can use the lambda value. Lambda is another good function, especially to create anonymous function. So right now, what did we do? Possibly here, right? Okay, we'll say square root or square. Let me write one. Okay, we are saying square of a number. So result is num square, return result. So then I'm saying square of 2. So initially I wrote a function called square, and then I tried to access that function by saying square of 2. This is a normal function way of writing. Whereas the same thing I can very well write, right? Sometimes, so this is the square way of writing. Yeah. So now I can very well have, instead of writing this entire function and naming that function as square and then accessing the value, I can very well say lambda. I can very well use the lambda keyword and say your input value colon your output value. Especially if your function is going to be executed in one step or in one line of code, you can avoid writing the name of the function, predefining the name of the function, and then using the name of the function, right? So you can very well say lambda num colon num square. So that is what will become the name of your function. So you are not using the def and square and those kind of things. You can directly access your square lambda. So that is where a lambda comes into picture. Another example. So you take lambda, take two parameters a comma b, and you say that your output is a plus b. So input, it takes two parameters. Output, it simply sums the two parameters. And so if you say add lambda 2 comma 2, it is coming out to be 4 because it takes a as 2, b as 2, and it gives a plus b. We'll try some more, right? Possibly here. Here, there are two outputs, right? So if I say, if possibly if I want, let's say something like this, some complex calculation. Otherwise, I'll have to give it in the form of a tuple. So if this is the calculation that has to come, then it calculates the entire. So because it is taking the inputs of a comma b, and it is calculating this output and it is returning this output, right? So many a times what can happen, otherwise what you will have to do, define some product difference, right? Define the product of sum and difference. That is the name of the function. Then you specify A, B as the parameters of the function. Then you say the computation A plus B star A minus B, return and print. So sometimes to avoid writing those complex, I mean not complex, multiple lines, just like the way we discussed, comprehension in case of for loop, and if statement and the expression. Lambda is for writing your own functions. Lambda is for writing the function without actually naming the function. Dynamically, for dynamically creating some kind of function, you can very well use the lambda notation. So possibly you can practice on those things. Yeah, I think someone is already answering some of the questions. So percentage is the formatting syntax where S denotes the string. You are right. What is the difference between return and print? Yeah, so return is like the value is saved and you can use it in the next calculation. Whereas in the print, you are just printing it to the screen and nothing beyond. It is not saved. Yeah, I think our friend KR Ashok is answering almost all the questions. It's a good sign. So possibly things would be much better. So just prints the result is lost and the return helps you to retain the result for further manipulation. So it's always better to have both of them unless you are just printing just for the sake of looking at the result. So then probably for verification, you should always do a print. But if you want to do a recomputation at a later point, then for better you take it into a return. Then the last function that I want to tell you before I move on to NumPy is the map. So this is one more important syntax. So here we are mapping a function to a particular set of values. We are mapping. Sometimes you may use lambda also inside the map. So we are mapping a function. So probably we have created some functions. We are mapping those functions to a sequence of values. Let's say I want to compute, right? I'm taking an example here. I'm giving you a set of Celsius values and I want to compute the Fahrenheit values corresponding to those Celsius. So I can do it in many ways. Probably I can write a function, right? I can very well write a function, Fahrenheit. So where I am saying divide 9, so 9 by 5 times T plus 32. Similarly, if I am converting the Fahrenheit to Celsius, I can say 5 by 9 into T minus 32. So this is just a function to compute. So let's say I want to find out for all these 4 different Celsius values, compute the Fahrenheit. So let's say I can do it in various ways. So this is, I am defining 2 functions called Fahrenheit, Celsius. Now for these 4 values, I want to compute my Fahrenheit, right? So one way is what I can say for I in temp, for I in temp, I can simply say print Fahrenheit of I. So for I in temp, I'll simply say print Fahrenheit of I. So this way what happens, or possibly I can very well say temp for I and temp, print I comma Fahrenheit of I. Or we will say Celsius equal to I comma Fahrenheit equal to this. So this is one way. Oh, this I did not run or what? So it says Celsius equal to 0, Fahrenheit equal to 32. Celsius equal to 22.5, Fahrenheit equal to this. So this is one way I can very well loop across all the entire temp, and I can very well print each of them. Whereas on the other side, I can use a map function. In a map function, what I'll do, because I have already defined a function, I will just map the name of the function and I will give all the sequence of input values here. I'll give the sequence of input values. So I don't need to run the loop separately here. I'm giving the sequence of input values. So every time, whatever are the input values that are required, it applies them to this Fahrenheit function. And based on that, it will give me the result. So this is like a map. One line, I am able to see the map. So you can very well look at you are mapping it and f temps. So you can very well, how do I access this? How do I display this? Okay, let me print. No. What is the type of this f temps? It's a map. Okay, list, right? Okay, you convert this map into a list. You convert this map into a list and then you can print it. So you have the values. Thanks a lot, Saurabh. So you convert this map into a list and you can print the values. Similarly, here, once you have done the map, you can convert that mapped value into a list and you can print the values. Right? Map Celsius f temps Okay, Celsius. No, what is the name of the function? I have taken Celsius only. F temps, I have to take it as the list. Okay, I have to take it as list of F temps. Map Celsius list. List of F temps. What is the value that it is giving? List of F temps. Where am I missing out? Hmm. See, F temps is the output that I have got. Celsius is the name of the function. So we have the Celsius, I have taken it as a small c itself. So I'm using that Celsius function. I think I have used, yes. I'm sorry. I'm sorry. I think I have been, oh no, SCEL, that's correct. Why is it creating a problem? List of F temps. No, these are the same, right? So why is this giving when I'm saying list of F temps? Hmm. Okay, otherwise I'll just say temp1, I'll just map it here. Temp1, I'm saving it as list of F temps. And let's say I'll call it temp1 for time being. Yeah, now it is working. So I think it's about the saving. So let us see, possibly we can come back to it. So I have simply saved this list of F temps as a variable called temp1. So I'm just passing on that temp1 here, and that is what it is giving me the result, right? So possibly I think it is not saving that stuff. So that's the reason I'm saving it to a separate variable, and the sequence of variables is what I'm bringing in out here. Now, in some cases, what I can very well do is I can avoid writing this. Now, if I'm bringing in the lambda, I can very well avoid writing this name of the function also, right? So what I can very well do now, let's say I want to use, possibly I'll continue with the same example. Right now, I don't want to write the function, right? So I'll say the same ftemp. Now, how do I use the lambda, this thing here? Instead of the Fahrenheit function altogether, I can very well say, I'll write a lambda. I'll say a lambda, possibly a C, which is a Celsius. I'll just take C as a Celsius is to, I will simply say 9 divided by 5 into C, 9 divided by 5 into C plus 32. So this is what I will map as temp. So which means now I can very well say list of f underscore temps. Now this time you see you're still getting the same 32 to 72.5 104. So which means one way is you write the definition of the function and you just give the name of the function there. Instead of function, you write a simple lambda argument. So this means without naming a function, so sometimes you can dynamically create the function on the fly. So in those kind of cases, you don't need to write the name of the function explicitly. You can still use the lambda. So lambda, map, these are some of the most common. I don't say common, but sometimes you can save a lot of your code and save a lot of your time also when you are using these kind of functions. So map is more commonly used with lambda expression, as we have just seen. Since the entire purpose of the map is to save effort on having create manual for loop. So you don't need to create for loop. So possibly you are creating for a sequence for all the values, one single function to be executed. Then you can give it as a lambda. Otherwise, map. Otherwise, if you don't use the map, as we have done earlier, I have to put a kind of a for loop. So for loop generally takes slightly more memory and more time, especially if we are talking of longer kind of processes. But map has a slightly different way. We can't get into the technicalities of them, but map has a slightly faster way of executing the result. Then map can be applied to more than one iterable. So sometimes you can even get multiple results also, as we have seen. So you can very well get. So you can say I'm using this, and you can give more number of values. So once you can give A, once you can give B, all these kinds of things, and you can very well print the multiple results as well. So that is what is about some of the basic functions. Of course, as you move, sometimes what happens is in Python, to a large extent, you just need to know the structures. Once you know the structures, the code for all of them is readily available in the public domain. So you just need to know how to write that particular piece of function in Python, and you would get the necessary help for doing the same. So that way, possibly you just need to know what each of these functions do. And sometimes what happens is, even without all these things, you may get used to writing a typical loop again and again. So, but just to avoid, see, sometimes your objective may be very efficient code. Sometimes your objective may be just meeting the functional requirement. So it all depends on how big a data set you are working, how complicated a data set you are working, etc. All right. So let me just look at the questions. Is map a different data type? Why you have used float? Here I did not use the float also. Float is to just give a little bit of more clarity into the answer. Right? Float is converting a number into a float. So even without that, I am able to manage it here, but this does not give a kind of a clarity. Sometimes what happens is, when I say a float of 9, it will take it as 9.0. That way, the division could become a proper float based division. So that's the reason whenever you are dividing by a denominator and you find it can result in a kind of a fraction. It's better to give a kind of a float in the numerator. Why it is giving only 4 values? Because my temp contains only 4, right? My temp contains only 4 values: 0, 22.5, 40, and 100, right? Possibly here we will say, instead of only 4 values, right? Possibly I'll keep it like this. I'll put one more. Temp 2 is equal to range 50, right? So range 50 is 0, 1, 2, 3, so on. So then I'll say f temps map temp 2. So for all the 50 values, now it should print 0, 1, 2, 3 up to 49. So you could see here, it has very clearly printed for all the values until 50. So you can very well, it does not necessarily give only 4 values, right? So yes, that's it. So which means we are done with some basic Python commands, right? It's not the end. I just tried to cover a few of them so that when you really take up the next, when we enter into the data and working with the data, it might very well be possible that and some more newer arguments can come into picture. Okay, so I'll just move on to the next important themed item for us. So now the NumPy. So basically here, as we have already discussed earlier, Python core am I audible? I'm getting some message that my listum resources. Okay, okay. Well, go ahead. It is needed to remember loop based or only remember. See, lambda does not work in all scenarios, right? For some simple functions, lambda can work, but if you are having some complex relationships and all, you have to define a function, mandatory. So it's not that you will avoid the functions always, only where some quick calculation, right? Just based on one or two parameters, 2 or 3 parameters, you are making 1 or 2 calculation. So in that case, lambda can solve the job. But if you are thinking of some complex relationships, and in some cases you cannot avoid loops, so function is not a kind of a substitution, right? You have to know function. Probably if you don't know lambda, if you don't use map, to a large extent you can still solve the problems, right? Only in a very few cases you may have to end up using lambdas and maps, because that's a part of slightly efficient programming. But from a functional programming perspective, even if you don't know the usage of lambda and maps, you can still get on with the loops. Yeah, one expression at a time. Correct. So for very simpler kind of scenarios, lambda can solve the job. But if you are going for some complex scenarios, complex calculations, etc., the output of the one going as the input of the other and all, it becomes slightly, or it becomes very largely difficult to represent it in the form of lambda. I hope it is fine. Vimal. Okay. So now I'm again getting into this NumPy. Now, as a part of this, see, Python, it is actually some set of functions we have already seen now. So Python contains some kind of data types. It contains some kind of data structures. It contains some kind of programming constructs like loops, if statements, etc. It contains some kind of modular programs like functions, etc. So this is what is a part of the core Python. But possibly we have already seen, if I had to do some kind of mathematical calculations, we have already imported one library called math. Import math. Which means not all mathematical calculations are present in this Python library, are present in this Python core. Few calculations are there, but not all mathematical functions are here. So, should I limit the usage of Python? Now, that is where different third parties, they started teaming up with this Python. Right? Python has given a framework. So, different third parties, they started teaming up with Python and they started writing extra functions using the base Python code. Using the base Python code, they started writing extra functions, just like the defs that we have done. So the external third parties, they started writing many additional functions using the base Python, and they had created a pool of functions. They have created a pool of functions. And basically what they have done, this pool of functions, they have created an independent entity of that pool. Independent entity, and that independent entity is what is called as a library or a package. So they have created a pool of functions as a library or a package. Sometimes that package even contains functions. Sometimes it can contain some additional data types, new data types. It can contain additional data structures, but over and top of the existing ones itself. And it can also contain some additional data sets also. So all these together can form one new library or some new package. Now this package is uploaded into the public domain. So for the Python, you will find PyPy. This is the public domain, Python interface, public interface. So where you will find the list of all the libraries that are associated with Python. List of all libraries that are associated with Python, you will find it in this website, PyPy. Okay. So, though there are few thousands of libraries, possibly few hundreds of them are really excellent and they have been used by few thousands of people and they have multiple stars also. You visit this particular website, PyPy, and you type the name of any package there. So it's a Python package index. So almost you could see there are 4,27,000 projects. Okay. So out of that, probably let's say I want to know about NumPy. So this is my NumPy. I could see here that there are 22,409 stars, right? Possibly the larger the number of stars, the popular that particular package is or library is. And forks are the ones that people have really created sub branches of it and they are working separately on extending those features. So which means this is a very, very standard kind of a library because the number of stars is too high. Possibly you look at the second one, NumPy 1, 0, 1, the NumPy 1. This is another package called NumPy 1. You hardly have any stars here. So you should not be confused, right? Even this is also one library, but it does not have any stars. So if it does not have any stars, what could happen is you may end up probably using some wrong functions or something, or possibly the function that was there in that may not be providing the necessary functionality also. You cannot trust that. So there are 10,000 plus projects which are just using the word NumPy, right? Python function for reading topaz result file. Then video reading into NumPy. So this is like video to NumPy. So possibly we could see there are 167 stars. So it is slightly okay kind of a package. So like that, possibly you may have to really look at, there are so many functions that are there, but which one is really suiting to our purpose is something that you may have to look at. Now, coming back, so all these independent functions, probably a kind of a NumPy package. So what we generally have to do is you import this package. So once you import this package, all the functions that are available as a part of that package are now available. You can work on all those functions which are available as a part of that particular package. So that is where most popular packages like NumPy, Pandas, so possibly the same kind of results you may get for Pandas. So Pandas 1.5.2 for data analysis, time series, and statistical analysis. Right, you could clearly see here 36,000 stars, 15,000 folks. So basically people have used Pandas, have been using quite heavily. Now possibly I say scikit-learn. So you say this is a scikit-learn, which is for machine learning. And what you could see is 52,000 stars are there. So possibly you could see that these are the very, very reliable libraries. But on the other side, let's say you see there is something called scikit multi-learn, right? So what is it happening? Multi-label classification. So let's say they have, so I want to know whether I should use this or not. So you see statistics, nothing is there. So if it is nothing, better don't get into a trap. Oh, it could be the same library as scikit-learn, possibly for multi-label classification, nothing like that, right? So possibly when you are trying to use some particular package, we should always see what is the stars associated with it, what are the folks associated with it, and so on. Once you import that particular library, you can directly use all the functions that are created as a part of that particular library. So now we'll quickly look at some of the theoretical stuff, and probably in the next class we will directly get on to working with NumPy. So numerical Python. It's a library consisting of multi-dimensional array objects. So this entire numerical Python, it works only with numerical data, first point, right? And it has introduced another new data type called n-dimensional array. So you will find that a new data structure, just like list, just like tuple, just like dictionary and set, in case of basic Python, NumPy has created one additional data structure called n-dimensional array. So one-dimensional array, two-dimensional array, 3D array, and so on. ND array, n-dimensional array. So you can perform various mathematical and logical operations on the array. So everything is treated as an array here. Here you don't have a list. When you are using any function of NumPy, please make a note of this point. You use any function of NumPy, your data is either in the form of an array or it is compatible to an array. So the functions can be applicable on the array, and the array are compatible with the array, and the output also comes in the form of array. So NumPy works very heavily with this data structure called array data structure, which is called n-dimensional array. So the most important object defined in NumPy, which is called n-dimensional array or ND array. So main thing is mostly it is numerical in nature. It describes the collection of items of the same type. In array, we are talking of the collection of items of the same data type. To a large extent, we are talking about integers or float, some kind of numerical value. Now, but there are some commonalities between the base Python and the functionalities that are offered in NumPy. So you can do a slicing, you can do an indexing, just like the way we have done in Python, right? Taking the first 3 elements, things like that. We can do all that kind of an analysis in NumPy also. But the only thing is, now it works on, earlier we worked on 4 data sets, data structures. One is the set, tuple, list, and dictionary. But now here we are working everything in terms of an ND array. And the purpose of doing this is, internally they have created the structures in such an efficient way that the timing of execution and possibly to a large extent, the loops can very well be avoided. So once you avoid the loops, you will be able to execute a lot of calculations much faster. Every item in ND array takes the same size of block in the memory. And any item extracted from ND array object by slicing is represented by a Python object. So probably you see here, you simply import NumPy. And NumPy has this array kind of a functionality. So you can very well create an array from the scratch, or if you already have your list, you can convert it into an array. So you have a Python list, you can convert it into an array. You have a Python tuple, you can very well convert it into an array. Now, the moment you convert it, you can very well use all the functionalities that are available in the NumPy. Now, because of that, your calculation potential can really increase, right? So you could simply look at one or two things, then we'll close. I'm importing NumPy. Generally, what we say is, rather than writing NumPy dot this function, NumPy dot this function, the most common packages, we actually have an alias for importing. So we say import NumPy as NP. Very commonly, of course, it's not necessary that you use only NP, but it has become almost a kind of a norm. So if I have this list, all I say is numpy.array. NumPy we have already created as NP. NP.array my list. So right now here it is in the form of a list. Now my output is in the form of an array. Similarly, you can have a two-dimensional array, the same list, where you have a list of lists. We have already seen earlier nested lists. So you give a nested list like this, and you say np.array of this. So it becomes a 3x3 kind of an array. So it can become a two-dimensional array, it can become a three-dimensional array, whatever it is. The moment you are using np.array function on the top, it will be of the data type ND-array. And ND-array is not there in the core Python. It's always a part of your NumPy. So possibly we will stop this here. I'll just see if there are some queries. Yeah, ND-array is very much mutable. You can convert from ND-array to a list. You can convert from a list to an ND-array or vice versa as well. Was that your question? Or replacing the values in the array? Even that can very well be done. So tuple is not mutable, but arrays and all are very much mutable. Okay. So I will stop this here. I will share this new sheet or a new notebook, whatever we have worked till now. So next class, we will try to complete NumPy because I'll cover only a few basic functions. And from pandas onwards, we are going to deal with data sets, right? Possibly we will start directly working with our data science based data sets itself. And we will first do some kind of pandas, and then we will move slowly, building up on the top of that course. All right. Thanks a lot, everyone. np.array. What is array? Yeah, array is the new data structure. The ND array, n-dimensional array is the new data structure. Okay. Yeah, thanks a lot, everyone, for listening to this session. We'll keep continuing in the next class. Thank you very much. Take care. Bye-bye.